You're chilling in Hawaii, on the island of Oahu. A friend calls you up. Hey, I'm here too. Meet me in Maui. Great, but how do you get there? Your first thought is probably to take a ferry, but that's impossible. Hawaii is a pretty unique place. It's the most expensive state to live in. It has its own official language besides English. And it's the only American state made up entirely of islands. Hawaii has a total of 137 islands. 8 are the main ones, but only 6 are open to tourists. And the distance between those islands is probably bigger than you'd expect. For example, traveling from Oahu to the Big Island is around 185 miles, which is about the same distance as Chicago to Indianapolis. You might be surprised that you can't make that trip by boat. In fact, the only ferry system that actually takes passengers in Hawaii runs between Maui and Lanai. That's it. So your only option is to travel between islands is by plane. Honestly, it's a little surprising, especially considering how many people visit Hawaii every year. Tourism pretty much drives their economy, and in the first 8 months of 2024 alone, over 6 million people visited its beautiful beaches. Knowing that, we would expect Hawaii to set up a good ferry system to make it easier for visitors to get around. Just like in Greece. This would probably boost tourism even more, bringing more money to the state. But believe me, authorities and private companies also know that. In fact, they've already tried it. Ferries were a big way of getting around in Hawaii from the 19th century up until the 1950s. Since then, there have been a few attempts to bring back a ferry service, but unfortunately, they have all failed. One of the biggest attempts was the Hawaii Super Ferry, which aimed to provide a fast, affordable boat service between islands. It could carry almost 900 passengers and even allow them to bring their own cars along. The trial run started in 2007, and people were excited, but it turned into a big fiasco. A bunch of legal and environmental issues came up, like concerns about the impact on marine life, especially whales. The courts decided the ferry didn't go through the proper environmental reviews, and that caused a lot of trouble. By 2009, after tons of protests and setbacks, they had to shut it down. If a project like this comes up again, it will probably fail one more time. And there are a few reasons why it's almost impossible to set up a regular ferry system there. Let's start by talking about Hawaii's rough waters. They are deep and wild. Take the Alenuiaha Channel, for example. It's a 30-mile stretch that separates Maui from the Big Island. Its name means Great Billow Smashing Channel, and it lives up to that. It's over 6,000 feet deep, making it one of the most dangerous stretches of water on Earth. The wind there is also super strong, the fastest in Hawaii's coastal waters. But it's not any easier in the rest of the archipelago. The whole region gets hit by storms from the Pacific up north, sending big waves crashing into the islands and making the waters rough and unpredictable. Swells can come from 3, 4, or even more directions, making the sea feel really choppy. Someone who's not used to taking ferry boats would definitely find that, well, uncomfortable, to say the least. To deal with rough seas like this, the ferries have to be really big and strong. But that also makes them more expensive and harder to run than the ones in places like Alaska or Washington State. Another reason it's so tough to set up this system today has to do with marine life. A big ship moving through the shallower waters when docking could really damage the local ecosystem. And there's also the problem that the sea routes are also the migration paths of many sea animals, like humpback whales and spinner dolphins. Not to mention, ferry services can make it easier to spread harmful plants and animals, what experts call invasive species. See, Hawaii's ecosystem is super unique because it's been isolated out in the middle of the Pacific. When we talk about plants and animals that are native to Hawaii, we mean they got there on their own, no humans involved. They arrived with the help of waves, wind, or even birds flying over. But events like these are super rare. So for over 70 million years, their plants and animals didn't have to deal with outside competition. That's made them really fragile. So, when new species get brought in by us, it can be a big problem, and they could end up harming the environment. Hawaii's already been battling invasive species like fire ants, coqui frogs, and Meiconia, a fast-growing plant from South America that takes over native forests. People there worry that ferries, which carry cars and cargo between islands, could accidentally spread these invaders even more. Like we mentioned at the beginning of the video, the long distances between their lands don't really help either. For example, if you were to travel from Oahu to the big island of Hawaii by boat, it would take around 30 hours, and that's without any stops. The same trip by plane takes about 50 minutes. Ferries that cover long distances are much more expensive, so they need a much bigger demand to make them profitable. On top of that, the state doesn't really have the infrastructure, like enough ports and terminals to support the operations. So setting up new routes is pretty much out of the question. Airplanes, on the other hand, are a different story. The air travel industry in Hawaii is already well established and super competitive. That means flying is still the most practical option in Hawaii. Planes are quick, they don't make you seasick, and are pretty affordable, usually costing around $100 for a round trip. Okay, but what do the locals think about all this? Well, apparently, there isn't a huge demand for residents to commute between the islands all that often. Oahu is the busiest island in Hawaii, with about 70% of the state's population living there. It is where Honolulu, the capital, is located, and where most of the state's business happens. So, people from the other islands usually come over for a specific doctor's appointment or to catch a big concert. And that might happen once or twice a year, no more than that. So, even if people could choose between taking a ferry and a plane for these special occasions, most of them would probably still prefer flying. There are plenty of options between the main island airports. Planes usually start flying around 5 in the morning, and there are flights available every hour until the last one, which is usually at 9 in the evening. If you've been dreaming of going to this paradisiacal place but are worried about spending too much on plane tickets, I have some tips for you. First off, keep in mind that visiting all the main islands in 5 days or less is way too ambitious. So, if you don't have much time to spend there, think about your priorities. Each of the 6 islands open to tourists has its own vibe and activities. But you don't need to visit them all in one trip, and you can save some money by sticking to fewer islands. You can still explore the diversity of the islands by picking 2 that offer a nice contrast to each other. For example, while Oahu has that bustling city energy, Kauai has a much more relaxed vibe. Also, flights in the morning are usually cheaper, and it might be better to fly on a weekday rather than the weekend, although the price difference isn't usually huge. Hopefully these tips will save you some cash while still having an unforgettable island hopping adventure in Hawaii. Don't forget to share this video with a friend who's also dreaming of exploring these amazing islands. I guess it's no surprise that it's not that easy to just hop on a plane and literally fly to the South Pole, aka Antarctica. Sure, there are airports down there, but they're not really set up for commercial flights. So most people go to Punta Arenas International Airport in southern Patagonia, Chile, and then take a boat if they want to see some penguins. But not only is it hard to fly there, it's even harder to fly over there. When you're cruising at 30,000 feet, you probably don't think much about what's happening below. But it's pretty unusual for flights to go directly over the South Pole, and planes flying across Antarctica are quite rare too. Technically, it is possible. I've already mentioned that there are airports there. But even so, the infrastructure down there is still super limited. There simply aren't enough airports or refueling stations to support regular commercial flights, making it tricky to operate in such a remote area. Plus, there are only a handful of specialized cargo and transport flights that go in and out, and they exist to cater to those few folks who actually live in Antarctica. Then there's the weather that drives up the costs. The simplest example is that the pilots there need special training, which costs money, which is all because of the weather. Another hurdle is something called ETOPS. These rules dictate how far twin-engine planes can fly from an airport. Since there are so few airports in Antarctica, it's tough for pilots to stick to these regulations. Historically, ETOPS made it next to impossible to fly close to or over the South Pole, while flights over land have plenty of airports to choose from. Antarctica is a whole different ballgame. These days, some aircraft can fly up to 330 minutes or, in rare cases, even 370 minutes from an airport. But even with those extended limits, certain parts of the airspace above Antarctica are still off-limits. Still, in the grand scheme of things, that might not be a huge deal. The most curious of you must have Googled that already and found out that there really are Antarctic airways. Please do not judge fast, and don't say I wasn't right saying how hard it was to fly to the South Pole. Let me break it down for you. Antarctic Airways advertise as the world's most exclusive transcontinental flight, but don't think you can just waltz in and book a ticket anytime. For starters, Antarctic Airways mostly operates flights to King George Island from December to March, so it's not all year round. But there are many more reasons why these flights are unique. If you dig into their website, you'll find you've got two choices: a full day in Antarctica or an overnight adventure. Prices kick off at $5,500 for a day trip and go up to $6,500 for an overnight stay. And if you're considering a private charter, get ready to shell out a pretty penny. It's rumored to start at around $125,000. Sure, that's a steep price compared to your average cruise ship crossing the Drake Passage, but here's the thing. It's about 20 times faster. A cruise ship takes 2 days from Chile, while Antarctic Airways gets you there in just 2 hours. Air travel to Antarctica is pretty limited, likely due to the high costs, limited seating, and the logistical challenges that come with flying to such a remote location. Plus, flights can often be delayed because of bad weather. Most travelers opt for a quick day trip or an overnight stay on King George Island, usually aboard smaller Beechcraft King Air 300 aircraft. The experience typically includes a stroll to a research station and a boat ride to see nearby penguin colonies, but that's just scratching the surface of what Antarctica has to offer. But once you're aboard Antarctic Airways, you'll see it's just like a regular flight on a smaller plane. You'll be served meals that have received some pretty good reviews. There are even photos floating around online showcasing the food, and honestly, it looks awesome. Those who've experienced it say it's luxurious yet unpretentious. You'll get a mix of meats and cheeses, plus treats like tiramisu, salmon salad, a single after-eight chocolate, and a selection of quality street candies. Today, everything may seem cool and safe, but back in the day, there were some pretty tragic events. On November 28, 1979, Air New Zealand Flight 901 tragically collided with Mount Erebus on Ross Island, Antarctica. Unfortunately, all 237 passengers and 20 crew members aboard lost their lives that day. Since 1977, Air New Zealand had been running regular sightseeing flights over Antarctica. This particular flight took off from Auckland Airport in the morning, with plans to spend several hours exploring the stunning Antarctic landscape before heading back to Auckland via Christchurch that evening. Initially, the inquiry into the incident pointed the finger at pilot error. However, growing public concern led to the establishment of a Royal Commission of Inquiry for a deeper investigation. The commission found that the crash had been primarily due to a change in the flight path coordinates made the night before, which the flight crew hadn't been informed about. As a result, instead of being guided by the computer down McMurdo Sound, as they were led to believe, the aircraft was mistakenly redirected toward Mount Erebus. In a way, this flight looks like modern one-day Antarctic tours. Flight 901 was marketed as a unique sightseeing adventure. complete with a knowledgeable Antarctic guide who highlighted various scenic spots and landmarks through the plane's public address system, while passengers enjoyed a low-altitude tour of McMurdo Sound. These flights operated as day trips, taking off from New Zealand and returning on the same day. The plane departed from Auckland International Airport at 8 a.m., aiming to land in Antarctica, with a scheduled return to Christchurch International Airport by 7 p.m. The total journey covered about 5,360 miles, including a 45-minute stop in Christchurch for refueling and crew changes before completing the final 464 miles back to Auckland, arriving at 9 p.m. Back in November 1979, tickets for these flights were priced at $359 per person, which is over $2,150 in today's money. Anyway, this tragedy isn't the reason why planes don't fly over the South Pole. The real culprits are weather, ETOPS regulations, and of course, penguins. Yep, those cool, friendly little creatures. Friendly, at least according to researchers. With no natural predators on land, all of them are in the water. They're not really afraid of people and actually seem to enjoy our company. The South Pole is completely uninhabited and packed with penguins, making it pretty tricky to build anything down there. By the way, the North Pole actually allows planes to fly over it. Not too long ago, there were direct flights from Copenhagen to both LA and Tokyo, operated by SAS, and they cruised right over the North Pole. Other airlines joined in too. For example, Emirates ran a flight from Dubai to LA that took the same route. The difference in air traffic between the two poles mainly comes down to where people live and how much land there is. Roughly 88 to 90% of the world's population hangs out in the Northern Hemisphere, while only about 10 to 12% call the Southern Hemisphere home. Most folks in the South are clustered around the equator in places like Indonesia, Central Africa, and Brazil. When it comes to flights heading to the South Pole, options are pretty limited. You mainly have routes connecting New Zealand and Australia, parts of southern South America, and a few spots in southern Africa, especially South Africa. There aren't really any direct flights over the South Pole, though some flights can get close to Antarctica. One possible route could connect Auckland, New Zealand to Cape Town, South Africa, but there aren't any scheduled flights for that right now. The few flights that came close to Antarctica are operated by Qantas and LATAM Airlines, linking Australia with Buenos Aires and Santiago de Chile. In 2021, Qantas took a long detour over parts of Antarctica on a flight from Buenos Aires to Darwin, and in July 2023, they adjusted a route closer to the continent to dodge some fierce headwinds on a trip from Santiago to Sydney.
So, there's a mysterious doorway in the middle of Antarctica. Some people think it's Bigfoot's vacation home, or a shuttlecraft from Star Trek, or maybe a door to Agartha, a mythical kingdom some people believe is located in the center of the Earth. Well, the scientists debunked all these poetic theories and explained that what looks like a mysterious doorway is located in an area of fast sea ice. It's offshore of the coast and is full of little islands with shallow water around them. When ice flows around hard rocks hidden underneath, it can create patterns that look odd but are totally normal. In this spot, the ice is thin, so the rocks underneath have a big effect on how the ice moves. The cold winds in Antarctica also shape the ice and snow and make it look like they're lines and shapes. So, the mysterious doorway is just a rocky ridge poking out because the ice has melted a little. The top of the doorway is the tip of the rock, and the sides are snowy trails left by strong winds blowing in the same direction. It's essentially an iceberg that got stranded and is melting in one place. One YouTuber found another out-of-place mysterious object more than 150 miles off the shore of Antarctica, a 400-foot-long ice ship. The internet went wild with theories like that the ship must have ended up there right from the Bermuda Triangle. But there was no scientific proof that it was a ship and not just a large chunk of ice. And once some other internet users revisited the place, they noticed the ice melted in the summer and the hypothetical ship was gone. Another mysterious Google Maps find in Antarctica was a pyramid. And before you make up an exciting theory about how the ancient Egyptians built a secret base here, I have to tell you it turned out to be just a mountain. It's part of the tallest mountain range in Antarctica that stretches for almost 250 miles. It's not the first pyramid on this continent, as explorers from the British Antarctic expedition found another unusually shaped mountain and nicknamed it the Pyramid. But this one didn't even have a pyramid shape. Here's one Antarctic find that definitely won't disappoint you: a giant ice shelf that reminded scientists of the Grand Canyon. A special submarine robot named RAN covered over 600 miles under the thick ice and brought back some amazing footage of icy mountains, valleys, flat plateaus, and swirly patterns made entirely of ice. One of the strangest things RAN found was giant bowl-shaped holes, or scoops, in the ice. Sadly, scientists lost track of the robot. They think that curious Weddell seals may have accidentally bumped into RAN and caused it to get stuck. To save energy, RAN probably shut itself down, and the scientists couldn't find it again. But the team is hoping to build a new robot and continue exploring this icy canyon to see how the patterns under the ice might change over the years. Another huge Antarctic canyon was found thanks to bad weather. A team of sound experts had to pause their work at the Casey Research Station in a storm. Instead of waiting around, they decided to use the unexpected free time to map the seafloor near Adams Glacier. And that's how they found a canyon that is almost 7,000 feet deep, almost 30,000 feet wide, and stretches over 28 miles away from the glacier. During the mapping, they discovered just part of the canyon before they had to go back to the research station. But when bad weather came in again, the ship went back and mapped more of the canyon. They were working in waves up to 13 feet high and super powerful winds, but they managed to get about 15 hours of data to complete their map. On the way back to Australia, they stopped one last time, and now they've got a full picture of the canyon. Studying it is helping scientists learn more about the history of glaciers and the interaction between the Antarctic ice sheet and the ocean. Now, there's a frozen lake in Antarctica called Lake Enigma. For a long time, people thought the lake was completely frozen solid. But during one expedition, researchers found that under the thick ice, there was a layer of liquid water about 40 feet deep. To learn more, they drilled through the ice and sent down a camera to explore what was hiding in the lake's depths. The lake's water, which they think comes from the nearby amorphous glacier through a secret underground pathway, was filled with strange microbial life. These tiny microbes lived in mats that covered the lake bed. Some of the mats were thin and spiky, and others looked like crumpled carpets, or even small tree-like shapes that grew up to 16 inches. Many of the microbes could make their own food through photosynthesis, just like plants do, and it gave the lake a high amount of oxygen. One of the coolest discoveries was a type of microbe which usually lives in low-oxygen places. Lake Enigma might be similar to environments on icy moons like Europa or Enceladus, so it could mean that these moons also have hidden water under their ice and possibly microbial life too. One more mind-boggling discovery from Antarctica is tiny pieces of amber in mudstone, found here for the very first time. It took scientists years of studying incredibly well-preserved fossilized roots, pollen, and spores that they found back in 2017. Amber proves that resin-producing trees once grew in Antarctica, part of a lush rainforest that existed near the South Pole during the mid-Cretaceous period. Back then, disclaimer, I wasn't around then, the trees would have had to survive through months of darkness during the long Antarctic winters. Scientists believe they adapted by going dormant for a long time. The amber pieces the scientists found are tiny, but they are beautiful shades of yellow and orange with bumpy surfaces that show how the resin flowed out of the trees. This resin likely leaked out to protect the trees from insects. It was preserved because water quickly covered it and kept it safe from sunlight and air. A scientist was browsing through satellite images for brown trails of penguin waste and found 4 new colonies of emperor penguins at the base of the globe. These new colonies likely have been around for years, though 3 of them are rather small, with fewer than 1,000 breeding penguins each. One of the new colonies was found close to a place called the Lazarev Ice Shelf, where there used to be a larger penguin colony. They thought this colony went extinct in 2019, but it seems the penguins have just moved a bit because of changing sea ice conditions. So studying them can help us learn more about how emperor penguins adapt to changes in the environment. Now, there used to be a giant river system in Antarctica 40 million years ago. Researchers found proof of it after studying soft sediments and hard rocks from the frozen seabed. They looked at tiny bits of radioactive elements, like uranium and lead, and learned that the deeper dirt came from the time of dinosaurs. The dirt closer to the surface was younger and had an interesting pattern, like the kind you see in river deltas today, such as in the Mississippi River or Rio Grande. Scientists found tiny signs of life in the sand. The river that once flowed here started in the Trans-Antarctic Mountains and traveled 930 miles before it reached the sea. Researchers kept studying newer layers of dirt from about 20 million years ago. They hope this will help them predict what the Earth's weather patterns might be like in the future. So it turns out that you can't drive between South America and North America, and there's a simple reason for that. There are no roads connecting the two continents, not even a rudimentary one. Technically, you could try your luck crossing on foot, but let me tell you, that would be a huge mistake. The region that connects the two continents is called the Darien Gap. It stretches across southern Panama's Darien province and the northern part of Colombia. The only land route there is a 60-mile jungle trek. Crossing it can take anywhere from 3 to 10 days. It depends on weather conditions, how much you're carrying, and, honestly, just pure luck. Chance plays a big role here, because this isn't some chill, relaxing nature walk. It's a harsh, extreme environment, known for being completely isolated and one of the most dangerous places on Earth. Still, people seem to forget that and go there anyway. Every year, the number of people crossing just keeps growing. In 2014, fewer than 10,000 people crossed the gap. In 2023, that number increased to 520,000. Now, you might be wondering, what are so many people doing in the middle of the two American continents, risking all that danger? Well, that's because the Darien Gap has become a route for refugees migrating to North America. But to get there, they face all kinds of dangers, from insect bites and infections to serious fractures. We're talking about a no-man's land. Since there are no police stations, immigrants must also watch out for thieves. Along the way, they have no choice but to rely on and support each other. Most people start the crossing with at least a tent or tarp, rain boots, water, and some food. But these things get heavy fast, and people normally can't carry enough supplies for the entire journey. At some point, people start drinking river water to avoid dehydration. But the water's full of bacteria and dirt, so it causes intestinal issues. And if things get serious, there's no medical help there. To make this whole scenario even worse, the temperatures are brutal, often hitting over 95 degrees Fahrenheit. Now, a small subset of people who venture through the Darien Gap are hardcore adventurers and travelers looking for a survival experience in the jungle. But this region is no place for a relaxing vacation. A group of tourists who went there in 2023 ended up getting jungle rot, a fungus that affects the feet. The situation got so bad that a woman had to be carried out by the group on the last day because she couldn't walk. No matter how prepared people are for the Darien Gap, in the end, survival mostly comes down to luck. Out there, travelers won't find cities with solid infrastructure where they can crash at a hotel and gear up for the next day. In some spots, they might stumble across basic camps right in the jungle. These camps might offer wooden platforms for tents, bucket showers, toilets, and even plates of chicken and rice. But it all comes at a price. Wi-Fi, for example, might cost $2 an hour, and that seems like a pretty good deal, considering there's no cell phone service on the trail. They pretty much lose all contact with the outside world. Now picture a dense rainforest with steep, muddy terrain. The hiking trail is littered with boulders and tangled with vines, like nature's own tripwires. It climbs sharply over a mountain, becoming a serious challenge even for someone in good physical shape. The area also gets constant heavy rainfall, which can lead to landslides, flash flooding, and extremely muddy conditions. The situation gets so intense that even the t-shirts and faces of those who make the crossing end up covered in mud. They'll also have to cross a lot of fast-moving rivers. A Venezuelan dad who recently went through the area with his 2 kids said their sneakers ripped apart on the very first day. That's how powerful the rivers can be. And they're deep, too. Sometimes the water reaches all the way up to their shoulders. But the dangers in that area aren't recent. For centuries, the Darien Gap was thought to be impossible to cross. The first Europeans who ventured into Latin America saw it as kind of a jungle training school. They totally knew about its dangers, but still, many adventurers tried to make the crossing in the years that followed. In 1854, for example, an expedition disappeared for 49 days in the jungle, battling starvation and exhaustion. Then again, in 1870, a group of 100 men set out to cross it. Even though they were well prepared and carried cutting-edge equipment for the time, they still suffered tremendously during the journey. They had to rely on incredible resilience to survive the challenge. Over the years, people who ventured in often ended up passing away from hunger, thirst, and even drowning in rivers. They also faced the risk of being attacked by dangerous animals like jaguars, white-lipped pecaries, and the fer de lance, a fast, irritable snake that is one of the most venomous out there. The area is also swarming with mosquitoes, which can spread serious health problems. Leaning against trees to rest can also be risky. This jungle is full of spiked chunga palm trees, which are covered in long black spines up to 8 inches long. Unfortunately for us, these spines are covered in all sorts of bacteria. Just brush against a chunga, and you could end up with infected wounds. And yet another danger is getting lost in the dense forest and never finding your way back to safety. These days, though, this risk is a lot lower. Some people have mentioned color-coded markers that help guide travelers and keep them from going the wrong way. If they see blue or green fabric tied to trees, it means keep walking. But if they spot red fabric, that's a sign they're going the wrong way and need to turn around quickly. Since there are so many dangers, why not just build a road through the Darien Gap? While it might seem like a good idea, building a road connecting Panama and Colombia isn't really that simple. The Darien Gap has a humid climate, tough terrain, and constant rainfall, which means any attempt to build a functional road would be highly challenging and super expensive. Even though there have been previous attempts to fill in the gap. See, there's a huge road system called the Pan-American Highway, which stretches all the way from Alaska to the southern tip of Argentina. Nowadays, this highway hits a roadblock right at the Darien Gap. But it wasn't supposed to be like this, as the original idea was for the road to go through there. Leaders from Latin American countries tried to make this plan happen in the 70s, and then again in the 90s. But a lot of people were against it, mainly because they wanted to protect the local communities and the rainforest. Since the Darien Gap is mostly untouched by humans, it's one of the most biodiverse places on the planet. It's believed that 1 in 5 species are endemic to the region, meaning they only exist in that specific area, like the Darien pocket gopher and the slatty slender mouse opossum. A road would have really damaged the ecosystem in the area, so the plans were scrapped. Eventually, an alternative was created to travel by sea. At least 2 companies started a ferry service connecting the 2 countries. However, the business wasn't profitable, and they ended up shutting down. Not long ago, Panama decided to close the Darien Gap route. Now they're sealed off with barbed wire fencing. It might just be a matter of time before other routes are created. But if you are an adventurer looking to visit South America, it's probably not best to wait for that. Traveling by plane to Colombia will always be a much safer option. So get this. Taylor Swift takes a flight from Los Angeles to Tokyo that leaves at 10 a.m. on February 20th. She's on the plane for 12 hours, but she lands only at 2 p.m. the next day in Tokyo. That's a 28-hour difference. So, how did this time warp happen? Well, it's all because of this wonky line. This is the International Dateline. You know, that imaginary line that slices the globe in half and decides who gets to celebrate the new year first? It's the Line Islands, by the way. But crossing this line doesn't just make you feel like you've stepped into a transporter. It actually changes your day. Cross from east to west and boom, it's 24 hours later. If you travel in the opposite direction, crossing the line from the western side to the eastern side, you go back an entire calendar day. Now, you'd think that the International Dateline would be a nice, neat, straight line in the ocean where the time zones switch. But in reality, it's as if someone took a ruler and said, let's make this complicated. The line zigzags all over the place, wrapping around islands and causing all sorts of head-scratching confusion. For instance, Big Diomede Island and Little Diomede Island are only 2.5 miles apart, but have a 21-hour time difference. And things can get a little more complicated depending on which time zone a country follows. For example, if you travel 659 miles across the dateline from Baker Island to Tokelau, you must add 25 hours. In other words, that's 1 day and 1 hour. And if that doesn't sound weird enough for you, wait, it gets crazier. When it's 6 o'clock in the morning on Thursday in New York, it's still Wednesday night in American Samoa. Meanwhile, over in Kiribati, it's already Friday. Yep, we're talking about 3 different calendar days happening at the same time because of this one imaginary crazy line. This phenomenon occurs every day between 10 o'clock and 10:59 in the morning. So, why does the International Dateline look so ridiculous in the first place? Well, great question. Although these zigzags may seem completely arbitrary, they actually have a logical basis. It's pretty much a made-up concept based on the Earth's rotation. The Earth is always spinning, thank goodness, and it takes about 24 hours, or a day, to complete one full rotation. To keep things in sync, people took the Earth and divided it into 24 time zones, each 15 degrees apart. But what is the starting point for a day on Earth? Well, basically, people needed to figure out which of these 24 zones or lines would be the starting line, or the chronocenter. They needed a reference point, a line where they could begin adding or subtracting time as you move east or west. That line is what we now call the prime meridian. But here's the catch. Deciding where to put this starting line, the prime meridian, is totally arbitrary. The idea of establishing a line where days begin and end goes all the way back to at least the 1300s. Back then, map makers were doing their own thing, picking their own east-west dividing lines called meridians, which, by the way, is just a fancy Latin word for midday. Without a universal standard for when a day officially started or ended, sailors on long voyages just had to wing it, figuring out how to handle the time they were gaining or losing along the way. So, in 1884, people decided to organize this whole mess. 25 nations gathered at the prestigious International Meridian Conference in the United States with one big goal: to decide on a line that would serve as the official prime meridian. Finally, like it or not, they were determined to create the international dateline that the whole world would accept and would follow from that point forward. The prime meridian was established in Greenwich, England, and the international dateline was placed on the opposite side, running through the 180th meridian. Well, sounds simple, right? But that's when the nightmare really began. The chosen international dateline didn't just wander through uninhabited areas. Oh no! It split some countries in half and created all sorts of chaos. I mean, if you divide the world with a completely straight vertical line, you end up with situations where half of a country is 1 day ahead and the other half is 1 day behind. Take Kiribati, for example. The country is primarily centered in the Gilbert Islands, which sits just west of the international dateline. However, in 1979, their territory got a little bigger with the Phoenix and Line Islands, which are way east of the dateline. Suddenly, Kiribati was straddling the international dateline. This created a bit of a headache for businesses. Folks on either side could only communicate by radio or phone for 4 weekdays a week. Now, to fix this quirky situation, Kiribati decided to skip Saturday, December 31st, 1994, right off the calendar. So Friday, December 30th, turned into Sunday, January 1st, 1995. And just like that, New Year's Day came a day early. Woohoo! After that, the dateline moved eastward to go around the entire country. So the same thing that happened to Kiribati happened to other countries as well. For example, when they got to the Aleutian Islands in Alaska, the line made another detour to include them. And when they got south of the equator, well, guess what? Another eastward bend to cover even more islands. And that's pretty much why the straight line started to get a bit ziggy-zaggy. This wonky line is designed to avoid land as much as possible, so there's less hassle when it comes to changing days. So, no, you can't stand between the international dateline, like having one foot in one day and the other in the next. But you can cross it by boat. In fact, some fancy trans-Pacific cruises even offer a time travel package for adventurous travelers who want to cross the line and jump into the future. Now, in the end, the international dateline looks this ridiculous because it was constructed based on a series of arbitrary decisions, historical quirks, and a whole lot of confusion. But it's not just because people organized it in the 19th century that there is no confusion regarding time zones today. Another thing that the prime meridian establishes is Coordinated Universal Time, the famous UTC. Now, UTC never changes for daylight savings time or anything else. However, in 1908, Canada decided to spice things up by creating Daylight Saving Time, or DST. Their idea was to set the clocks 1 hour ahead of Standard Time to make better use of sunlight in the spring and summer and fall evenings. The idea was so brilliant that most countries jumped on board, but not everyone. Just look at Nepal. They have never ever used the Daylight Savings Time, which means their clocks do not change throughout the entire year. As you probably know, countries with large territories often have more than one time zone. Just like the United States, which has 11 time zones. Australia has 9, while India is a special case. Look, India is a big country with an area that stretches around 1,800 miles from west to east. So it should have 3 time zones in total, but they only have one. This means that the sun rises almost 90 minutes earlier in Dong in the Far East than in Gujarmoti in the West. And why do they have only one time zone? Well, basically, because they can. Just remember that the international dateline and time zones are invisible, artificial, and now you know, totally arbitrary. So if a country wants to stick with just one time zone to simplify processes and business operations within its border, then hey, why not? Surprise! There's more than 7 continents on our planet. Argoland, a hidden continent, may help us understand how our planet will look in the future. To find out how it hid from us and what secrets it holds, well, you'll just have to keep watching. Ready for a mystery? Scientists have been looking for a piece of land that's been missing for over 100 million years. Not exactly newsworthy, since people search for information about our planet's history all the time. You'd think it was probably this minuscule island somewhere in the middle of an ocean. Well, you'd be wrong, because this continent used to be as big as the entire U.S. territory. For a long time, geologists have been wondering whether a massive chunk of contemporary Australia vanished into thin air. Some believed it was simply hiding somewhere on the ocean floor. But thanks to some Dutch specialists and 7 years of investigating, we now know there are bits and pieces of this lost land mixed underneath the lush jungles of Southeast Asia. The continents we see in our geography manuals these days are like scattered pieces of a puzzle. There's even a nice experiment you can conduct to see for yourself. Find a world map online and print it out. Cut out all of the continents and play around with them for a while. You'll see they all fit together. Probably the most striking thing you'll see is how South America perfectly fits near Africa. If you close up the oceans that were formed in the last 200 million years, the continents look like they form a giant letter C. And that C is what scientists call the supercontinent Pangea. It was swimming in an ocean called Panthalassa, and the inner portion of that letter C had a smaller stretch of water called the Tethys Ocean. It is in this small ocean where things get interesting. Back in the Jurassic period, this vanished continent, which scientists started calling Argoland, vanished and left a hole in Australia, now known as the Argo-Abyssal Plain. Geologists initially believed this was all due to a process called subduction. It's when one piece of the Earth's crust dives under another and recycles it into the planet's mantle. Usually, specialists track this continental vanishing through off-scraping. That's how they figured out, for instance, that India bumped into Asia and gave us the majestic Himalayan mountains. But for Argoland, things were a bit more complicated. Bits and pieces were popping up in places like Myanmar and Indonesia, but they behaved like these time-traveling relics, looking way older than when Argoland supposedly separated from Australia. It immediately raised the question, if one continent can behave so weirdly, how many others are out there doing the same? Thankfully, scientists have now put together the entire timeline of Argoland and figured out its mystery. It didn't sink or get swallowed up. It simply transformed into an archipelago, breaking into smaller pieces, called microcontinents, and floating away from Australia. These mini-continents then took a little journey before settling down in Southeast Asian jungles. This discovery fits right into the whole Pangea puzzle. It helps us better understand how continents break up and make up, all in one discovery, revealing secrets of biodiversity and climate back from in the day. If you'd like to find out more secrets about history, civilization, or random day-to-day objects, be sure to like this video and subscribe to the channel. Like, for instance, the mystery behind this invisible species line in Indonesia. It's called the Wallace Line, named after the British explorer Alfred Russel Wallace. Over 150 years ago, Wallace was on a journey around the Malay archipelago, visiting thousands of islands. What he found was that animals on one side of this invisible line were considerably different from ones on the other side. This invisible line is like a wall between marsupials and tigers, for instance, or honey-eaters and trogons. But now we know that around 35 million years ago, Australia broke up with Antarctica and collided with Asia, and this continental love triangle triggered significant changes. It didn't just change the way the land looked, it also messed with the species of animals on each side of the Wallace Line. In more recent times, a bunch of specialists published a study saying this collision and climate chaos made Asian species comfy living in the Malay archipelago. Meanwhile, the Aussie animals weren't as happy with the new environment. It was too hot and wet for some, and others just couldn't handle the tropical island lifestyle. The discovery of this continental shift towards Asia might also explain a recent finding of a human species that didn't seem to make any sense either. You see, in this hidden cave in the Philippines, archaeologists stumbled upon a new human ancestor. It seems that about 50,000 years ago, on the island of Luzon, there was this ancient human-like species. The lead researcher believed this finding was crucial for understanding human evolution in Asia, and it named this new species after the island, Homo luzonensis. Now, here's where it gets a bit confusing. The bones found by archaeologists had one small problem. They had a weird mix of traits that hadn't been seen together in any other hominid species. Smaller teeth, similar to ours, yet hands and feet that were more like our ancient humanoid ancestors. It was those throwback limbs in particular that connected this human species with the long-lost Southern Territory. That's because they have this primitive look, like these hard-to-pronounce guys, for instance. Only these two species are separated by 2 to 3 million years of time and evolution. Many have wondered, is Homo luzonensis really a new species? Not everyone is convinced. But it may also explain why living creatures are also affected by the constant shifting of the land underneath us. Now, just because they haven't changed much during our lifetime, it doesn't mean our continents will look like this forever. They evolved from this large megacontinent, and they'll most likely end up in a similar position in the future. On that note, a geologist from a European university tried to predict the future of Earth's supercontinents. As a starting point, he used an earthquake that occurred in Portugal back in 1755, when tectonic plates behaved a bit differently than they should have. After years of research, he came up with a theory in 2016. He believed that the stitches between these tectonic plates might be coming apart, setting the stage for a bigger rupture. It's like when glass cracks between two holes in a car windshield. If this happens, A subduction zone could stretch from the Mediterranean all the way up past Ireland, bringing volcanoes, earthquakes, and new mountains to these areas. If all goes according to this plan, the Atlantic Ocean will disappear, and so will the Pacific, turning into one large stretch of water. Instead of the 7 continents we know today, we'll get a new supercontinent, which he called Arica, because it would have Australia and the Americas at its heart. Now, it's not the only possible scenario, though. Novo Pangea might be another, and it's easy to foresee. The Atlantic stays open and the Pacific closes. Then there's Amasia. For this one, you'd have to imagine the Arctic Ocean closing and the Atlantic and Pacific staying open. Everything shifts to the north around the North Pole, except Antarctica. One final scenario would be called Pangea Ultima. Slow down the spreading in the Atlantic, and a new subduction plate pops up on the America's east coast. Well, either way, if all the continents collide in the future once more, some say it won't be fun to experience. It's believed that in around 250 million years, we'll feel like we're being trapped in a sweltering, soggy plastic bag. Weirdly, that bag will be the best place to live on Earth, the coastal areas. As for the inland spots, they'll be sizzling, like a desert on fire. Many of the species of animals we know today might not make it. As for us humans, we'll need to be creative if we want to withstand the heat. We should be thankful, though. These digital models are still great because we can use them to test all sorts of interesting ideas. For example, how these supercontinents would mess with tides. Taking future space travels into consideration, these models can help us understand the climates of exoplanets too. Those are located outside our solar system. Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other landmasses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's 8th continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The Lost Continents landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritius. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steps of Mauritius. They found a mineral that exists in rocks which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Sahul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the Greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species developed differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Sahul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangea was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangea started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that.
Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallacea and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylacoleo. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now, the islands are home to unique species both on land and in the coral reefs nearby. Mauritius broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future. This invisible line divides the world into two parts, and most animals, fish, and birds, for some reason, can't cross it. The line is called the Wallace Line, and it runs between Australia and Asia. It has its name after Alfred Russel Wallace, a British scientist and explorer who discovered it in 1859. He traveled to Asia to explore a group of islands called the Malay Archipelago. As Wallace walked through the jungles, climbed hills, and sailed on boats, he noticed something like an invisible wall. On its west side, in places like Borneo and Sumatra, he saw animals you might find in Asia. There were big rhinos munching on leaves and monkeys swinging from tree to tree. The forests were full of life, with all kinds of animals you'd expect to see in a jungle. But in places like Sulawesi and Lombok, just across the imaginary line he came up with, Wallace found animals more like the ones in Australia and colorful birds like cockatoos. The behaviors of animals differ on different sides of the Wallace Line. Some creatures are great at traveling across tough barriers like water, but others are not. For example, bats can fly across open water, but they sometimes cross the Wallace Line. On the other hand, big animals that live on land like elephants usually stay on just one side of the line. Some birds are shy and like to stay hidden in thick bushes and trees to avoid predators. They wouldn't feel safe flying over wide stretches of water with no place to hide. Plants don't stick to the Wallace Line as strictly as animals do, because they spread in their own unique ways, like with seeds carried by the wind, water, or animals. One plant genus, the eucalyptus, mostly stays on the Australian side, but one eucalyptus tree has made its way to the Philippines on the Asian side. Underwater, the Wallace Line doesn't matter as much. The area between the Wallace Line and Australia is called the Coral Triangle, and it's bursting with life. Now, after more than 150 years, scientists think they finally have an explanation of the Wallace Line mystery. They believe it all started about 35 million years ago, when Australia broke away from Antarctica and slowly moved up to crash into Asia. When this happened, the crash created a chain of islands called the Malay Archipelago between Asia and Australia. This caused extreme changes in the weather, which made the area very different and affected which animals could live there. Researchers used a computer model that looked at how more than 20,000 species of animals from both sides of the Wallace Line would have behaved millions of years ago. When Australia started to drift away from Antarctica, it opened up a huge new era of deep ocean around Antarctica. This is where the biggest ocean current on Earth, called the Antarctic Circumpolar Current, began to flow. This swirling current made the planet's climate much cooler and completely changed how animals could live in different places. But not all animals were affected in the same way. Indonesia stayed warm and rainy, which was perfect for animals from Asia. These creatures could hop from island to island like stepping stones and make their way toward Australia. But animals from Australia had a harder time. Over millions of years, they had gotten used to living in cooler, drier places, so the tropical islands didn't suit them as well. Scientists believe if we can see how animals adapted to big changes in weather patterns millions of years ago, we might be able to predict how today's animals will cope with a similar situation. Other scientists after Wallace also tried to describe and explain the invisible natural border between Asia and Australia, and came up with their lines. The Weber Line, for example, is in a slightly different location than the Wallace Line, between the Oriental and the Australasian faunal regions within Wallacea. It's a group of mainly Indonesian islands that are separated by deep water straits from the Asian and Australian continental shelves. They were never connected to the big continents by land, so animals that could swim, fly, or float across the water made it to these islands. That's why the creatures living there are so unique and come from both Asia and Australia. Weber's line is where the balance tips. If you go one way, most of the animals are from Asia. If you go the other way, most of the animals are from Australia. Another important migration event in the history of our planet happened in the Americas. Around 30 million years ago, South America became a separate landmass as tectonic plates moved and pulled it away from Antarctica and Africa. Once it was on its own, the animals living there started to evolve in unique ways and turned into creatures you couldn't find anywhere else in the world. There were animals we still see today, like opossums, giant rodents like capybaras and chinchillas, armadillos, anteaters, and sloths. Some of the animals from those times are now extinct. There were giant ground sloths, bigger than cars, roaming around. There were glyptodonts, which were like giant armadillos with super tough, bony shells. There were also huge, scary birds that couldn't fly but could chase down their prey. Up in North America, animals could still travel to other parts of the world through the Bering Strait. So North America was full of different animals like deer, bison, horses, camels, and even mammoths and mastodons. They all lived alongside predators like big cats, wolves, and bears. About 3 million years ago, the continents of North and South America got connected by a strip of land called the Isthmus of Panama. It formed because the tectonic plates shifted again. Some major volcanic activity between 25 million years ago also contributed to the process. Animals started to move between North and South America, and this long process went down in history as the Great American Interchange. During the Ice Age, huge glaciers in the north grew and shrank over tens of thousands of years. When the glaciers were at their biggest, they held so much water that the sea levels dropped, and forests probably turned into wide grassy plains. So animals had the perfect conditions to cross over. Giant ground sloths were among the animals that went up north from South America, all the way to Alaska. One special kind even roamed the chilly tundras alongside woolly mammoths and caribou. Lots of North American predators decided to explore the South. There were cats like cougars, jaguars, and saber-toothed tigers with their giant teeth. Wolves, foxes, otters, raccoons, and bears also joined the migration. The short-faced bear could stand up to 13 feet tall and weigh as much as a small car. South America also had some funny-looking animals called sanus, or South American native ungulates. These were hoofed mammals that evolved into all kinds of weird shapes, while South America was isolated. Big animals from North America, for example, relatives of elephants with strange tusks, came to the south and became some of the largest creatures around. The ancestors of today's llamas settled in the Andes Mountains, and deer, tapirs, and peccaries thrived in the forests. Animals kept moving back and forth between the continents for thousands of years. But as the Ice Age ended, many of the bigger animals, like the giant ground sloths, couldn't adapt and disappeared. It seems North American animals were better at adapting to their new homes. You can find armadillos, porcupines, and opossums from South America in North America. But many of South America's most famous animals like jaguars, llamas, and spectacled bears left North America long ago. Scientists think South America's animals, after being isolated for millions of years, had a harder time dealing with new challenges when their ecosystems changed.
Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangea, or Pangea if you're feeling fancy. The name comes from a Greek word which means all the earth. Pangea also had a massive water neighbor called Panthalassa, so our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things change. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learned their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their four paws. And it's unlikely that this particular type of animal originated in two places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figured out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangea, Pangea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So if these secret tunnels will be spreading and spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years. You'd be surprised to find out the life-changing discoveries a person can make just by browsing Google Maps. Like this guy, who found a suspicious crater and might have made a major scientific discovery. In 2024, Canadian Joel Lupoint was planning a casual camping trip in his homeland. He opened Google Earth and zoomed in Quebec's Côte-Nord region. That's when he saw it, this unusual rounded structure. The measurement was impressive, 9.3 miles from one point to another, and there seemed to be a lake next to it. He was quick to print the screen and sent the image to a French geophysicist to see if he knew anything about it. Most times these images turn out to be nothing, or simply Google Earth watermarks. But he was surprised when he opened his email and saw the scientist's reply. The geophysicist said that, judging by the looks of the topography, Lapointe could have discovered a meteor impact area. Now, impact areas are really hard to identify. Since they've been around for millions of years, most of their shapes have been heavily changed by erosion. Scientists call these areas impact structures. They're usually circular or crater-like and are made up of deformed bedrock. It happens when a meteor falls into the surface of the Earth. Here's the thing. Since the crater has huge walls around it, these areas are usually mistaken for mountain ranges. That's what left the Canadian explorer confused. But the French geophysicist that analyzed the case gave him hope. That weird formation in Quebec had been classified as a type of volcanic formation. After Lapointe brought this subject back to the agenda, scientists had to dig a little deeper to find the truth. Until this recent discovery, scientists thought the area looked like that due to some volcanic formation. This is actually normal, since other things such as volcanism and sinkholes can be mistaken for impact craters. To verify, they asked for some samples of the site. This is a more reliable way to fact-check whether a meteor landed there or not. When the meteor hits the Earth, it brings different types of minerals from outer space. That's the wonderful thing about impact craters. They reveal a link between Earth and the outside universe. By now, scientists have cataloged most of the minerals that are native to our planet. When they're searching for an impact structure, they usually look for things such as teenite and chemisite, which can only be found in meteors. The biggest known impact crater in the world is the Vredefort crater, located in South Africa. This big thing was formed some 4 billion years ago. The asteroid that made it is estimated to have been one of the largest ever to strike planet Earth. When the researchers got the results of the site back in Canada, they did confirm that it contained zircon, a mineral that tends to show areas of impact. There's no way to guarantee that Lapointe really found an impact crater, but scientists are organizing a research mission over to the area just to make sure. If it turns out that it really is an impact crater, that's pretty huge news, since the last discovery was made in 2013. Another one of these mesmerizing discoveries came from a 15-year-old boy. William Goddery was also a Canadian, and for some reason loved looking for long-lost Mayan cities. Different from the previous story, William had an intention and a research methodology. He had studied many books on Mayan civilizations. He believed that Mayans built their cities in relation to the stars in the sky. So he opened a book and mapped all the cities that have already been unearthed. And that's when he noticed something important. There is an area in the Yucatan Peninsula in Mexico where archaeologists have unearthed 2 Mayan cities. But on the constellation map, there are 3 stars. He thought to himself, could this mean there is a lost city waiting to be discovered nearby? William Goddery is known to be a science genius and has even won an award for this constellation theory. When he noticed that a 3rd city was missing from the 23rd constellation he was examining, he began to search Google Earth for satellite pictures that could help him solve this mystery. Advances in satellite tech have shed new light on long-lost Mayan cities such as Tikal. Located in the heart of the Guatemalan jungle, Tikal is believed to have been the capital of the ancient Mayan Empire. He had hopes, so he reached out to a friend inside the Canadian Space Agency to verify what he had found. Since he had already won awards for his research, he had friends in high places, and that's when things got interesting. According to the images, there was a large square area on the border of Mexico and Belize that looked like the remains of a city. William took the images to a remote sensing expert. They studied the images thoroughly and concluded that the area could be housing 30 buildings and even a large pyramid. William named the new city discovered as Mouth of Fire. However, his theory was very much contested inside the archaeological community, and many Mayan experts worked to debunk William's findings. Experts say that constellation theories are too unscientific. Renowned anthropologists and astronomers said William's methodology was an act of creative imagination. Still, a 15-year-old teen almost found a long-lost Mayan city, which is pretty exciting if you ask me. What about these tiny dots that appeared on images of Google Earth? These strange spotted circles were found in the middle of the Algerian desert. A YouTuber browsing on Google Earth found these circles and discovered that people had been debating over their origin for years. He thought they were a glitch from satellite images. There are dozens of them, stretching for miles and miles in a straight line. They're far away from any town, road, or human activity, making it hard to understand if it was man-made or just a natural phenomenon. To settle this mystery, he interviewed the people who took Google Earth's pictures. He found out they were 100% true. The circles were there in real life. They appear in multiple pictures from multiple years. Now, at first, he guessed they were the result of oil activity. Algeria is a rich area for natural resources, so this made sense. To find out if the area is worth extracting, companies usually undertake seismic surveys. They're a way of analyzing the Earth's surface by sending shock waves into the ground. Depending on how these waves bounce back, you'll know what is located underground. There was another possibility. The Sahara is a very dry area of the planet. The average high temperatures in summer are over 104 degrees Fahrenheit. To survive there, people need to find ways of accessing water. So, his second guess was that the circles were kind of ruin or leftover from ancient water wells. But when he talked to an expert, he found out they weren't ancient water wells. You can see some of these traditional constructions in other cities on Google Earth, and they look really different from the mysterious circles. He decided to travel over to Algeria to find out the truth. He drove 99 miles into the heart of the desert, and when he gets there, he sees it. A huge crater dug on the sand, surrounded by 12 smaller holes. It kind of looked like the ancestor of a modern clock. There, he found something he couldn't spot on Google Earth: thin metal wires. When the curious YouTuber and his teams started to dig in the sand, they found old dynamite and some sardine cans. Apparently, they were hiding the truth. The Sahara Circles, as they were famously called, were not the historical leftovers of seismic surveying. Back at the time when these circles were made, this technology didn't even exist, but they were sure related to oil exploration. The dynamite holes were an ancient method of oil searching, and the sardine cans? Well, they were left by the workers who were exploring the region. Another Google Earth mystery solved. Ooh, you're diving into the dark and icy waters of Antarctica. The airy blue darkness is enveloping you, reminiscent of the vast expanse of open space. In these depths, where you least expect to encounter any living creature, you suddenly hear a loud, strange sound. A quacking noise, as if a giant duck was hidden in the deep. In 1960, researchers first recorded this sound and named it bioduck. Clever. For decades, they tried to unravel the mystery of its source. Was it a giant kraken? An extraterrestrial spaceship that had crashed into the ocean? A mysterious sea monster? Or perhaps an enormous duck? There were many versions, one more bizarre than the other. Oceanographers detected similar sounds in other locations as well. Off the western coast of Australia and near New Zealand, they recorded similar but higher-pitched signals, which they named bio-goose. It seems the creepy atmosphere of the story disappears with such names. Anyways, these sounds were not isolated incidents. They happened multiple times with consistent intervals. Many initially thought the source must be mechanical, given the regularity of the sounds. However, studying the oceans in the latter half of the 20th century was challenging because of limited technologies. Nevertheless, scientists persisted in collecting data on bioduck and biogoose, driven by their insatiable curiosity. As more data accumulated, so did the theories. But scientists eventually uncovered the mystery. Bioduck turned out to be a form of communication with a biological origin. When researchers analyzed the repeating sounds, they noticed that the signals never overlapped. One source would speak while the others remained silent, suggesting a form of communication. The question remained, which ocean creature possessed such an extraordinary method of communicating through varied frequency sounds? The answer, as many have guessed, is whales. Scientists compared the bioduck sound from Antarctica with the calls of minke whales and found striking similarities. The biogoose sounds from the waters off Australia and New Zealand likely belong to other species or very young minke whales. This discovery, however, only deepened the mystery. What purpose did these sounds serve? Were the whales discussing their dinner plans, laughing at the humans recording their voices, or perhaps sharing deep insights about the universe? The possibilities were endless, but the most astonishing revelation was that humans might one day learn to communicate with these magnificent creatures. Communicating with whales is no longer a far-fetched idea. Scientists from the University of California have already established contact with a humpback whale named Twain. In a groundbreaking experiment, researchers conducted a 20-minute conversation with the marine mammal. Here's how they did it. The specialists went on a marine expedition to the coast of Alaska, where they recorded the sounds of a group of humpback whales. Then they played these sounds through speakers, sending the signals back into the ocean. The recorded sounds resembled a greeting, like, "Hey, what's up?" but in the whale language. These greetings are used by whales to call each other or indicate their location. Now, soon after sending the signals, the researchers received a response. Twain approached the boat, circled it, and replied with a "hey" of its own. This marked the beginning of the first ever human-whale conversation. For 20 minutes, the scientists sent 36 signals to Twain, and each time the whale responded. Moreover, it waited for time intervals before answering. That is, the team received a response from the whale, waited 10 seconds, and turned on the sound again. Researchers then waited 10 seconds and answered. It seems that Twain was a very delicate interlocutor. Maybe it was a gentleman in the whale world, who knows? Or maybe it was simply intrigued by the unusual interaction. The signals used in this communication belonged to a group of whales that included Twain. It's likely that the researchers had recorded Twain's own sounds and used them to communicate with it. In a sense, Twain was conversing with itself. Now let's continue our journey and venture into the deepest oceanic trench on Earth, the Mariana Trench. A quick reminder, the Mariana Trench is a colossal chasm in the ocean floor, stretching over 1,500 miles south of Japan and reaching a depth of nearly 36,000 feet at its deepest point. To put that into perspective, the height of the Burj Khalifa, the world's tallest building, is like 1/10 of the Mariana Trench's depth. Now imagine this. In this deep, dark abyss, scientists recorded a strange sound. Unlike bioduct, this sound resembled something from a science fiction movie, a low rumble, followed by a metallic ping, reminiscent of the sounds made by spaceships in sci-fi movies. Researchers named this mysterious phenomenon biotwang noises. Scientists first detected this strange sound in 2014 during an acoustic survey of the Mariana Trench, and they quickly identified its source: whales, specifically Bride's whales. Using artificial intelligence, researchers analyzed around 200,000 hours of audio recordings from the ocean and found matches with a group of Bride's whales. Like other animals, these whales use sounds as a form of communication. Now, did you know what else was found at the bottom of the Mariana Trench? A plastic bottle. It's unlikely it was done by a kraken or a whale or some type of monster. Everything is simpler here. The bottle ended up there because of a human. But that's a topic for another video. Okay, let's deal with one more sound. No whales this time, just a mysterious sound in the loneliest place on Earth. This place is called Point Nemo, and that's why it's so lonely. Located in the South Pacific Ocean, Point Nemo is the most remote spot from any land. The nearest island is 1,450 nautical miles away. It's about the same long distance from land in all other directions. Moreover, here, there's almost no marine life, since few water currents reach this spot, and therefore few nutrients are supplied. In a sense, it's a water desert. And so, in 1997, oceanographers recorded a very strange and frightening sound coming from the depths in the area of Point Nemo. It was something gigantic and scary. People called it the bloop. As soon as journalists found out about this phenomenon, people around the world began to invent the most fantastic versions. The most popular of them was that the sound's source was a giant sea monster, kraken, or some other creature. The hype around the bloop didn't last very long. Scientists managed to find out the nature of the mysterious noise. It turned out it belonged to an iceberg. When they crack and collapse, they create powerful ultra-low frequency sounds that can be heard from a very long distance. To confirm this version, scientists recorded the sounds of other icebergs and heard something similar to the bloop. Oh, by the way, Point Nemo is so lonely that space agencies drop out-of-service satellites here. Space objects just fall in the water. There's a 99% chance that no animal or human will be harmed by falling debris in this lonely place. That's why many people call it the satellite cemetery. But what if, someday, a spaceship from another planet falls here? What if it has already fallen in Point Nemo and sometimes emits an emergency signal that breaks through the ocean? Ooh. All the mysteries you have heard have already been solved. How about we end this video with a mystery that still baffles scientists? Meet upsweep. One of the most mysterious sounds ever recorded in the ocean. It's not just noise, it's a series of short ascending tones repeated at intervals of several seconds. It was first discovered in 1991 using hydrophones installed in the Pacific Ocean. At first, oceanographers suggested that upsweep could be associated with volcanic activity or underwater earthquakes. But the seasonal nature of the sound and its intensity change depending on the time of year, which rules out these versions. People began to consider hypotheses related to the biological life of the ocean. They studied the migration routes of marine animals and their behavior at different times of the year. However, despite all efforts, the sound source has not been identified. Some studies suggest that upsweep may be associated with certain species of fish or other marine animals that make sounds for communication or navigation, but no one has been able to prove it. So, the distance from New York to Lisbon, on the other side of the Atlantic, is well over 3,000 miles. At the average walking speed for a human, you could trek there in a month and a half. That's not counting the rest stops and much-needed sleep. Buying an airline ticket or boarding a ship aren't just better options, but the only travel possibilities right now. But if this long journey on foot became possible one day, would you be up for the challenge? The most obvious obstacle is all that water in the Atlantic Ocean. It covers around a fifth of the Earth's surface. All the oceans take up around 70% of our planet. When you open the tap or buy a bottle, you are drinking a tiny percentage of potable water. 97% of Earth's water is located in oceans. It's all salt water, and it's not drinkable. Add this 2% of water trapped in glaciers and ice sheets, and you get less than 1% of water that we actually drink. When you put these percentages into numbers, you'll need a long sheet of paper to write them all down. The U.S. Geological Survey estimates that there are over 330 million cubic miles of water in the world. It's essential for sustaining all life forms, including humans. Oceans play a vital role in regulating air temperature around the globe. If they didn't have any water, the area around the equator would be scorched. This imaginary line that divides our planet in half runs through 13 countries in total, such as Brazil, Kenya, and Indonesia. The world's oceans are critical for our planet's water cycle. You know, like the one you learned about in school? It rains from the clouds and water eventually ends up in rivers that empty into the oceans. Then sunlight warms up this vast body of water, so it evaporates into the atmosphere to form new clouds. Then the cycle starts over. This process shapes the global climate. That's why, for example, the Mediterranean is so popular for the summer holidays. The region is temperate. If we take the oceans out of the equation, the water cycle stops. The area where they once sat would turn into a huge dust bowl. There would be dirt as far as the eye could see. Since there is no more evaporation, clouds won't form. Rain would become scarce. Humans would soon run out of sources of drinking water. The landscape of our planet would turn into a vast desert. Imagine a Sahara-like terrain stretching across the surface of our planet. Everything would become so dry that fires would break out easily. These are hardly the ideal conditions for a long trek between continents, but let's imagine you were able to survive all this. You start walking across the desert land that was once the Atlantic Ocean. What would that journey be like? You would encounter a landscape different from the one above the waterline. Everything below the waves is taller and deeper than the world we know. This is the land of extremes. Take, for example, the highest mountain on the planet. If you were thinking about the Himalayas and its tallest peak, Mount Everest, you are correct. Well, kind of. This mountain range is the highest when you measure it from the sea level, just above 29,000 feet in height. But when you measure the height of the mountain from its base to the peak, then the Himalayas drop to second place. The highest mountain on Earth is actually Mauna Kea in Hawaii. It's a dormant volcano. In the local language, its name translates as White Mountain. Nearly half of it lies under the waves of the Pacific Ocean. Its full height is close to a mile higher than Mount Everest, at 33,500 feet. We can't appreciate its scale right now, but if the Pacific dried up, we would be able to stand at the base of this giant. The bottom of the Atlantic hides a similar mountain range. It's the largest geological feature on the planet. We can't see it because the mid-Atlantic ridge is almost completely submerged. It rises from the ocean floor to a height half of that of Mount Kilimanjaro. The width of the massive underwater range reaches 1/10 of Earth's diameter. The only visible sections of the mid-Atlantic ridge are islands such as Iceland and the Azores. The remotest inhabited island in the world also belongs to the visible part of this geoformation. Perhaps the only thing more impressive than its size is the date of the discovery of its ridge. Scientists charted it out in the 1950s. That's pretty recent when you consider our civilization is thousands of years old. This shows how little we know about what's hiding under the surface of our oceans. UNESCO estimates that humans have explored only 5% of Earth's oceans. It seems hard to believe, but more people have been to the moon than at the bottom of the ocean. The deepest place on our planet lies in the Mariana Trench. The discovery of the Mid-Atlantic Ridge revealed the secret behind the formation of continents and oceans. When you know the truth behind their origins, you'll know what to expect on your imaginary trek across the Atlantic. The ridge sits right between North America and Europe. But you need to think of these landmasses not as continents, but as tectonic plates. These are huge chunks of Earth's outer layer. It's called a lithosphere, and is mostly comprised of rock. There are around 15 to 20 such ginormous plates on our planet. They float on a layer of partially molten rock. Well, they don't actually float, but that's the term scientists use to best describe their instability. Tectonic plates are constantly on the move. They can bump into each other. In this case, one plate goes down while the other one is lifted. This creates vast amounts of energy. On the surface, we get earthquakes and volcanoes. Tectonic forces gave our planet its familiar shape. That's how the Himalayas formed 40 to 50 million years ago. Around that time, the Indian plate shifted northward. It bumped into the southern part of the Eurasian plate. Since the two plates were composed of a similar type of rock, they each refused to go under the other. The only possible direction was up. This process is still not over. The range grows by 1/3 of an inch every year. A similar thing is happening with the Mid-Atlantic Ridge. It is widening at an annual rate of 1.5 inches. And there's an interesting side effect of this process. Do you remember the time when you were building sandcastles? In order to build the keep, you needed to dig up a lot of sand around it. As the castle grew in size, the hole around it became bigger. The same thing is happening in the Atlantic Ocean, but on a much larger scale. As the ridge is getting wider and wider, the two coasts are drifting away from each other. The North American plate and the Eurasian plate are moving apart. This means that your imaginary trip in a world without oceans might take longer. For every year you wait, you'll need to cover an extra inch. Now, that doesn't seem like much today, but give it some time, and you might not have to embark on a cross-continental journey after all. The continents will come to you. Now, evaporation is not the only way to drain an ocean. The coast on each side of an ocean might simply close in on it. This is what scientists believe will happen to the Pacific. Some 50 million years from now, give or take, you wouldn't be able to recognize the Earth's largest ocean. Experts ran a series of computer simulations to see where North and South America are headed. The answer is to the North Pole. This is where they'll merge with Asia in the distant future. The new supercontinent will completely change the shape and size of the Pacific Ocean. Geologists have a name ready for this landmass: Pangea.
Phew, you can finally send that last report for the day and breathe out. The weekend is around the corner. But just when you're about to hit send, you're alarmed by the low rumbling under your desk. Is it the light rail passing by? Unfortunately, that's not the case. It's a volcano speaking. What, here? In Arizona? That's right, the ground keeps shifting under Arizona, reminding us that Earth is alive. No panic though. Let's arm ourselves with some context. 20 American states have extinct, active, and dormant, currently sleeping, volcanoes. Among such states, you can find California, New Mexico, Nevada, Utah, and Colorado. On the bright side, Arizona's volcanoes are dormant at the moment, but it doesn't mean they won't go off in the near or not so near future. Now, how about traveling to Arizona to check the traces of its active volcanic past? They dot the desert landscapes of this state like spots dot a Dalmatian. There are entire volcanic fields southwest of Phoenix, east of Douglas, near Flagstaff, north of Kingman, and near the Mexico border. The most worrying thing about these fields is that even though they're not active at the moment, eruptions in this region might happen every 1,000 years or so. Well, the time seems to be up. The last powerful and destructive volcanic eruption occurred around 1,000 years ago at the Sunset Crater. Oh, this place is worth paying more attention to. And we will, but a bit later. First, we have to talk about hotspots. No, not that place where you can surf the web. In our volcanic context, a hotspot is a place where insane amounts of heat melt the overlying crust, Earth's thin outer layer, and form volcanoes. This heat rises from the mantle, which is located between our planet's dense, superheated core and the crust. Want to see an example of this type of volcanism? Welcome to the Hawaiian Islands. The Big Island has its active volcanoes because, at the moment, it's situated on top of the Hawaiian hotspot. The older Hawaiian Islands were once there too, but later they drifted off towards the northwest. It happened because that's where the oceanic crust on top of which they sat, namely the Pacific Plate, moved. Now, look at the world's ocean basins. Yes, they're literally dotted with islands that sit on top of hotspots, like Hawaii, Iceland, Samoa, the Galapagos. Those are probably the most famous examples. But don't think that continents can't host hotspots. They can, but those are far less common. One of the most famous continental hotspots is, I bet you know it. Yep, the one beneath the Yellowstone caldera. By the way, the caldera is a vast volcanic crater, especially one formed as a result of a massive eruption that led to the collapse of the mouth of a volcano. The Yellowstone hotspot is basically the creator of Old Faithful and the rest of the hot springs and mud pots for which the national park is famous. Speaking of Old Faithful, let's make a small detour and pay more attention to this wonder of nature. It's one of the most well-known geysers in the world. People have been coming from all over the globe to see it for more than a century. The cool thing about this geyser is that the likes of it can only form under very specific conditions. That's why they're pretty rare. Magma under the surface superheats pockets of underground water. The pressure there keeps growing until it eventually pushes the water upward with immense strength. A certain volcanic rock with a high silica content lines the tunnel through which this water escapes. Basically, it creates a unique pipe that can withstand unbelievable pressure and heat created by the water erupting above the ground. Old Faithful was the very first named geyser in Yellowstone. If you come to visit it expecting the thing to erupt every hour on the hour, you're gonna be disappointed. On average, Old Faithful erupts every 91 minutes or so, which isn't that bad either. Plus, you can download a special app which will provide you with the approximate time of the next eruption. But be very careful while visiting and stay away from the site. The water erupting from the powerful geyser reaches 204 degrees Fahrenheit. The steam is even more scorching, up to 350 degrees Fahrenheit. It's hot enough to bake a cake. But let's get back to our volcanic hotspots. Scientists still don't clearly understand why there aren't many hotspot volcanoes on continental crust. One reason might be that the continental crust is much thicker than the oceanic crust, which is about 4 times as thick on average. Another reason could be that most of Earth's crust, about 2/3 of it, is oceanic. This means that there's less continental crust for hotspots to form under. Now, I bet those of you living in Arizona will appreciate the following info. We'll talk about a volcanic field right in the heart of this state, the San Francisco Volcanic Field. That's a massive area filled with over 600 volcanoes. Yes, they're mostly small, but it doesn't make them any less impressive. They're scattered across 1,800 square miles in northern Arizona, a giant territory. Interestingly, scientists are still debating about whether this volcanic field is actually sitting on top of a hotspot. But one thing they agree upon, the volcanoes in this area get younger as you move east. And this pattern matches up with the North American plate moving west over what could be a stationary hotspot beneath the surface of our planet. Cool, huh? The volcanic hullabaloo in that area started around 6 million years ago. So, in geological terms, it's relatively young. As for the most recent eruption, it happened less than 1,000 years ago. The Sunset Crater, which I mentioned before, the one near Flagstaff, is the most famous vent from that eruption. The Sinagua people had to leave their homes at Wupatki Pueblo because of the eruption. That site is now part of the Wupatki National Monument. There, you can see how people lived in this volcanic region many years ago. If you go to explore this area, you'll notice that most of the volcanoes there are basalt cinder cones, small and steep. The Colorado Plateau has quite dry weather conditions. That's why the volcanoes haven't worn down much. Some of the best examples of those cones, like this one, called the SP crater, still look like they appeared yesterday. But look around. It's not just cinder cones. The San Francisco Volcanic Field also has a stratovolcano, as well as some lava domes that formed from volcanic rocks with more silica than basalt you can find in places like Hawaii. It means they're thicker and don't flow as easily. Anyway, the stratovolcano is going to be one of the most epic sights you'll come across while exploring this volcanic field. Well, not the stratovolcano itself, but the San Francisco peaks, the remains of that giant formation. They stand tall at more than 12,600 feet. That's 4.5 Burj Khalifas placed on top of one another. It makes the peaks some of the biggest landmarks in northern Arizona. They're not only stunning, but also sacred to the Native American people who have lived in the area for many generations. Now, unlike those super active volcanoes in Hawaii, the San Francisco Volcanic Field takes its time, thousands of years between eruptions. But you shouldn't relax just yet. Geologists say another eruption is likely to happen one day. It will probably occur in the remote eastern part of the field, away from big towns. Phew! And if that next eruption is anything like the one that formed Sunset Crater, it would be quite the show. Lava fountains and rivers of lava flowing. At the same time, the next eruption might not happen for centuries, maybe even millennia. Until then, the San Francisco Volcanic Field will remain a hidden gem of volcanic history, waiting for its next fiery performance. This sleek, state-of-the-art submarine named Ran was sent to explore the depths of Antarctica. But as soon as it discovered something, it mysteriously disappeared. So, what happened? It all started when scientists wanted to explore one of the most remote and mysterious places on Earth, the Dotson Ice Shelf in West Antarctica. This ice shelf, silent giant, stretches 30 miles wide. That's almost the length of New York City. It stands between two icy promontories, the Martin and Bear Peninsulas, and it hides an entire world of geological mysteries. If you think that Antarctica is nothing but a desert of super thick snow and ice, you're wrong. There are entire landscapes hidden deep down there. The underside of the Dotson Ice Shelf is a rugged, dynamic terrain shaped by the slow, relentless forces of nature. There are towering ice formations, deep troughs, and bizarre structures stretching for hundreds of feet. Scientists are super curious about it, but as you can imagine, this landscape isn't easy to explore at all. To find out more, we have to scan the area with satellites or try drilling through the snow, trying to collect the big picture, piece by piece. But these methods only gave us vague hints. The real breakthrough happened when scientists came up with the idea to let the submarines explore it. Autonomous submersibles could swoop deep into the icy waters beneath the Dotson Ice Shelf and tell us what's up down there. These robotic explorers have fantastic advanced sonar systems. It's that thing that bats or dolphins do. They can use sound to see the world. Basically, they send out sound waves underwater, and when those waves hit something like the ice shelf above or the seafloor below, they bounce back to the system. Animals feel how long it took for the sound waves to return and how they changed. And this helped them understand what's located where. For example, clicks that dolphins send out tell them where the fish are. We copied this crazy evolutionary trick and adapted it to our underwater exploration. Only our version is much cooler, with a higher level of precision, so we created detailed maps of the environment. The Rand submarine was one of those robotic explorers. It was named after the Norse deity of the sea. Ran had been meticulously programmed to navigate a treacherous landscape of Antarctica. But even with all this training, its journey led to an unexpected and eerie end. In 2019, Ran was sent to explore the depths beneath the Dotson Ice Shelf. It was a hero, the first one to go on a mission like this. The team said it was like seeing the other side of the moon. For 27 straight days, it worked tirelessly. It traveled over 620 miles beneath the thick ice. That's like a journey from Paris to Berlin. Ran went further and deeper than anyone could have imagined. At one point, it reached over 10 miles into the glacier's belly, and what it discovered down there was astonishing. Scientists thought there would be some smooth, uniform ice surfaces, but Ran revealed an underside marked by huge cracks, ridges. There were formations that looked like sand dunes, frozen in time. And finally, it found some mysterious swirling and teardrop-shaped patterns. They all looked more like art than geology. This actually tells the story of ice shelves and the ocean around it. Warm water sneaks in under the ice and melts it from below. Sometimes it smooths the ice out, but other times it carves out these weird, uneven shapes that look like patterns and drawings. And some of these shapes are huge, over 1,300 feet long. That's about 3.5 football fields. The reason why they look like swirling doodles is because the Earth spins. It makes the water turn in special ways, bending the shapes and drawing these spirals. It's called the Coriolis effect. Imagine you were on a merry-go-round and tried to throw something like a ball. It would go in a curve, not a straight line. Same thing happens with the water on Earth. Later, scientists found similar patterns in other Antarctic ice shelves, though they weren't as epic as the ones under Dotson. But Ran also discovered something horrifying. Turns out that these warm waters, aside from being great artists, are also a huge danger. The Dotson Ice Shelf isn't just hanging out serenely on the sea. It's part of a very delicate system and acts as a protective barrier that holds back huge glaciers in West Antarctica. The ice shelf is floating on the ocean, but it's still connected to the land. As warm water sneaks underneath it and the ice melts, the Dodson can't hold on to the land as tightly anymore. The protective barrier starts to weaken, and this lets the glaciers behind it move faster into the ocean. When those glaciers flow into the sea, they add more water, which could cause sea levels to rise, eventually changing our coastlines. Rand stumbled upon huge pockets where the ice was melting at alarming rates, all due to powerful underwater currents. It was like seeing a ticking clock on the glacier. The stakes were high, but luckily the submarine was ready. This time, it managed to return. And then, it worked for 5 more years, helping scientists with tons of useful data. The missions were daunting. There could be periods where Rand slipped into the pitch-black cavity beneath the glaciers, spending 24 hours without communication. But it was mapping every peak and every valley. It gained experience from over 40 missions below ice. Then, in early 2024, Rand went on a mission to the Thwaites Glacier. The mission was bold from the start. This place is also ominously referred to as the Doomsday Glacier. It's called that because it's slowly melting and has the potential to raise sea levels worldwide if it collapses, causing catastrophes everywhere. That's why Rand was dispatched to explore its underbelly, a place that had never been mapped so intricately before. The idea was to uncover the glacier's secrets, study how rapidly it was melting, and why. This was Rand's second time exploring Thwaites. During the previous visit, it became the first sub to ever map the glacier's underside. Rand was exploring the depths from 650 feet to 1,650 feet. It sent a lot of data about how the Doomsday Glacier was slowly melting due to warm ocean currents. But while venturing into these icy depths, something went wrong. Out of nowhere, Rand vanished. Without warning, without a trace. One moment it was sending back crucial data, and the next, it had slipped into the abyss. No distress signals, no final transmission, and it didn't return to the point it was supposed to. People sent extensive searches, helicopters soared overhead, drones buzzed through the frozen skies, but no sign of the submersible emerged from the glacier's grasp. After a while, Rand's batteries would certainly run away. So at this point, it had definitely been swallowed by the abyss beneath 1,500 feet of ice. That was a huge and sad loss for the scientific team. The scientists at the University of Gothenburg are now looking to replace Rand and continue their important research under Thwaites. To this day, scientists have no idea what happened to it. Some say it may have been trapped in the ice. Others believe it was pulled away by an unseen current. It also might have collided with something unexpected. Whatever the truth is, its disappearance has left scientists stunned, and it looks like the ice shelf will hold on to its secrets a little longer. At least we gained a treasure trove of knowledge from Rand's journey. Scientists keep exploring Antarctica, looking for history that hides under the snow. For example, they discovered that around 90 million years ago, a lush temperate rainforest thrived near the South Pole. They revealed an ancient world far warmer than they ever imagined. Deep in Antarctica, they unearthed fossilized roots, pollen, and spores preserved in the soil. All this shows that there was a swampy rainforest that flourished despite months of polar darkness. All these discoveries changed our understanding of Earth's climate, both in the past and the future. The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangea. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangea began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangea's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, That piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research, but this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritia, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritia was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritia was covered in water when India broke away from Madagascar, something like 85 million years ago.
The world's largest fence spans over 3,100 miles from Queensland to South Australia. If stretched out, it could easily connect London to New York. And if you'd walk next to it, you'd need 6 months to complete the journey. It wasn't built to safeguard the Australian border. Why would it, since Aussies are just surrounded by water? It wasn't meant to protect some important building either. Its purpose is to keep some animal species away from each other. It was back in the late 1800s when Australians started building parts of this fence. They wanted to create a barrier separating the lively, bustling part of the country where cities like Melbourne and Sydney thrive from the harsh, dry outback. They used wooden posts dug deep into the ground, linked up with wire mesh standing about 6 feet tall. Some parts of the fence even have a second electrically charged layer. To make sure this fence did its job, they added some red and white lights to help guard things even at night. A team of over 20 people work full-time to keep things in check here. And every year, local authorities chip in around $750,000 to keep the construction in shape. Why all this trouble? The main reason was dingoes. These gingery, wolf-like creatures are Australia's largest carnivore mammals, and they're also apex predators. They were causing a lot of trouble to local farmers, especially in southern Queensland, where they often go after sheep. For the most part, the fence has been doing its job okay, but it's not foolproof. Some dingoes still manage to sneak through. Other times, wild camels end up crashing into it. That's because Australia has quite a massive camel population roaming around. But this man-made solution did more than locals expected. They thought there would just be fewer dingoes within the fence, but fewer dingoes mean more kangaroos. And more kangaroos mean more competition with the sheep for food. It's not just the bigger species feeling the squeeze. The smaller animals and the greenery also went through changes. With all this competition in a smaller space, locals noticed less diversity in the plant life and small animals. The soil became less nutritious over time, affecting plant growth. Plus, the fence acts as a roadblock for animal migration and seed dispersal. Even the sand dunes are feeling the effects, with less grass cover to hold things together. When scientists looked at kangaroos on both sides of the fence, they noticed that the young pups inside were lighter and tinier on average. The outsiders had bigger feet and heads for their age, and it wasn't because they were eating a different diet. The kangaroos that were stuck sharing the land with dingoes had to bulk up faster to survive. On the flip side, those inside the fence took it slower because they weren't under the same type of pressure. These had to compete with a lot of other creatures for food, so a bigger size wasn't a priority anymore. Researchers are still not sure if this difference is a quick fix or a long-term gene adaptation. What about domesticating dingoes? Wouldn't that help? Many think dingoes were once pets in Australia, but it's not known for sure. These days, they're pretty wild, just like wolves, hyenas, or coyotes. Most of them don't need packs to survive and are solitary hunters with sharp instincts built in. So taming them isn't going to be easy. Still, taking down the construction is not an option for now. Australians are so strict when it comes to making sure dingoes are kept away that they even put laws in place for people who mess up with the fence. Leaving a crossing gate open can put people behind bars for up to 3 months. Damaging the fence can cost people 6 months' worth of their freedom. It wasn't the first time Australians thought a fence could help with animal issues. Before they needed it for dingoes, they experienced a serious bunny invasion. Cute as they are, rabbits were damaging the land used for farming, so locals thought of a 3-part fence. The first one stretched all the way from Ravensthorpe in the south to Pardue Station on the Pilbara coast. It was over 1,100 miles long, making it the longest unbroken fence globally at the time. All these bunny problems could have been traced back to a man named Thomas Austin. Back in 1859, when he first came to the land down under, he thought it would be a good idea to release a few rabbits into the wild, thinking it would add a bit of charm to the place. But since rabbits aren't native to Australia, they didn't have any natural predators at the time. They're also pretty adaptive creatures, needing just some grass for feeding. They reproduce at astonishing speeds too. A mama rabbit can have 4 litters a year, with as many as 5 bunnies each. Pretty soon, their numbers boomed. By the late 1880s, the bunnies had caused so much damage that local authorities came up with a proposal. They'd offer the equivalent of almost $2 million today to anyone who could come up with a solution to this long-eared problem. Nobody claimed the prize, but a commission did gather a bit over a decade later and came up with the fence idea. Maintaining those fences was complicated. They had inspectors keeping an eye, with each one responsible for a stretch about 500 miles long. There were also these boundary riders patrolling smaller sections, using bikes at first, then switching to camels or using camels to haul buggies. They even tried using cars at one point, but they couldn't handle the rough terrain and constantly had punctured tires. In terms of its effectiveness, well, by 1902, rabbits were already hanging out on the wrong side of the fence. That's why, 4 years later, they put up another one. It worked for a while, so much so that the local authorities didn't bother helping out farmers past that second fence with rabbit netting loans. Those caught between the 2 fences, however, still had a rough time dealing with rabbit trouble. Soon enough, rabbits spread even over fence number 2, and it was clear the solution didn't work. In some areas, even while the fences were being built, those sneaky bunnies found their way past them. To this day, the rabbit population still sometimes puts the Australian officials through rough times. The dingo fence may be the longest one, but it's not the weirdest. The aquarium fence in Turkey might take that prize. This 164-foot aquarium fence was built to make sure the expensive villa's ocean view would be visible from every one of its levels. These days, it gathers a lot of tourists from all over the world, eager to see the variety of fish it contains, and even the octopuses. Putting up a see-through structure wasn't hard. The real challenge was connecting the aqua fence to the Aegean Sea through a buried pipeline stretching across 13,000 feet of land. This ensures water constantly flows, keeping the aquarium clean and the fish happy. To make sure no one damages the delicate fence or steals any of the fish or two, the owner also invested in security. He installed a network of 17 cameras equipped with facial recognition. Visitors are free to look and take pictures, but step too close and you're likely to trigger alarms. Another one of those weird fences is New Zealand's bra fence. If you ever find yourself through central Otago, you might stumble upon a fence adorned with bras of all kinds of shapes, sizes, and patterns. Its story takes us back to 1999, when people in the area found 4 bras mysteriously hanging on the fence near Cardrona Valley Road. Some were a bit surprised, but then others started adding their bras to the decor. Some more bras appeared and it became a must-see spot for tourists. Its popularity was so high that at times it caused traffic problems in the area.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.